we're going to analyze a pump. A pump is a device where you will need, for instance, an input of electrical, usually electrical, it could be mechanical work, such that you will have, for instance, the entrance of a liquid, and this has to be a liquid, otherwise it's a compressor, and the liquid will exit with a difference of pressure. So there is a difference of pressure, and we use, for instance, a liquid. And the conservation of mass will state that the mass that enters is going to be equal to the mass that goes out, such that, for instance, area 1 velocity 1 over specific volume 1 equals area 2 velocity 2 over specific volume 2. But in this case, the specific volumes are the same because it's a liquid, so we only will remain with area 1 velocity 1 equals area 2 velocity 2, which is, for instance, the volumetric flow. And the conservation of energy will state, for instance, that work at the inlet, so the work in plus the heat in plus the U plus PV, which is the enthalpy in, plus K in plus, which is the kinetic energy, plus the potential energy in, is equal to everything else out. We can actually write this equation as the change in, so the change in work, the change in heat, the change in internal energy, the change in PV, plus the change of the kinetic and potential energies has to be equal to 0. And in the pump, for instance, we will have a work, so this will remain. But usually we don't have, for instance, a change in heat. And since this is a liquid, the change in the internal energy will also be 0. And unless, for instance, the kinetic energy changes, right? That could happen. This will yield to 0. And usually the change in potential energy is negligible. So at the very end, what we will have is, for instance, that the work that we have to input to the pump, there is no output of the pump, has to be equal to the change in PV. And when we develop the change in PV, for instance, this will be, for instance, the change in, or let's say, the volume times the change in P plus P times the change in volume. And since the volume is not changing, because this is a liquid, then we can get to the conclusion that the work in the pump is going to be equal to V delta P, unless, for instance, you change also the velocity, which then you have to add the change in kinetic energy. But the conclusion here is that the work for the pump is going to be equal to V delta P.